Hi!
My name is Ginevra Gaviraghi, and I am a student in Galileo Galilei in Gravellona Toce, Italy.
My name is Martina Guia Zagonen and I am a student of the Cavalieri High School in Verbania, Italy. Today we're presenting the Apex project. The space elevator, with its ground and orbital terminals connected by adequate cables, is set to revolutionize space transportation. Replacing conventional chemical rockets, it will significantly reduce costs, enable the movement of heavy loads, and foster ambitious business ventures. This proposal explores using the space elevator for constructing intermediate settlements and establishing a robust transportation infrastructural network across the solar system, supporting future exploration and development. Beyond its transport capabilities, the space elevator's orbital terminal can serve as a way station for Earth space operation, facilitating the efficient manufacturing and logistics. Equipping other solar system bodies with similar systems could create an interconnected network of terminals and ground bases, providing affordable and accessible pathways to key solar system destinations. We are at level zero point 0.7 of this Sapientia scale. We must reach 1.4 level to have space settlement capability. Our goals are promoting an affordable space transportation system, space settlements as business proposition for space economy, manufacturing settlements as products, supporting solar system development. The general mission can be divided in three general phases. Phase 1: assemble the first settlement at the Apex Antler location. Phase 2: utilize the new facility for two major business activities. Serve as a way station for outgoing and incoming interplanetary vehicles, and assemble additional settlements equipped with space elevators to be deployed on other bodies. Phase 3: build and deploy space elevator systems for third party organizations on other celestial bodies and initiate local activities. Various configurations have been proposed for space settlements tailored to their specific functional requirements: the torus, the dumbbell configuration, the sphere, and the cylinder. In our case, the inclusion of a space elevator terminal, the only non-rotating part of the settlement, is essential. Therefore, we propose a torus-shaped settlement consisting of a modular self-contained components that rotate around a central longitudinal hub. This settlement comprises two rings in rotation. The innermost ring, called transfer ring, connects via spokes to the outer ring, ensuring stability, functional integration, and pod transfer between fixed and rotating volumes. This element will be a torus-type ring-shaped volume with habitat pods connected with the external ring. The structure of this element will be based in a series of components to form a ring-shaped configuration rotating around the central hub. Such rings will connect at the modular pods to the system, allowing to obtain artificial gravity G1. All structures will be composed by 90% titanium and 10% aluminum for needed strength. The central hub, due to the location of the space elevator terminal, only no rotating system in this element, will be composed of a rotating ring around the terminal or connected by spikes to the other more external rotating shape. In the same axis, it will be connected to another big torus ring that will house the future manufacturing activities, including mineral storage for processing and transformation in needed metals. Additional roles and functionalities for this element include space-based final assembly and launch facility, technology testing site, manufacturing of new space elements, spaceport for extraterrestrial vehicles, maintenance on the overall of space vehicles, node for an infrastructural transportation system including the entire solar system, spaceport to the other missions, and supply solar power generated in orbit, and construction support and refueling space vehicles in space. The proposed settlement will include the following features: 1G gravity, expandable habitat modules, scientific laboratories, asteroid storage and processing, spaceport, space debris management, life support systems, medical facilities, food production units, solar power generation for terrestrial consumption, and manufacturing stations. The additional requirements will also influence settlement configurations: radiation protection, artificial gravity, meteor collisions, resource acquisition, and habitat expansion. The first generation settlement's primary operational model will be the pod. Main reason is to have the settlement operational in a much shorter time than a more conventional but larger shape. This will be connected to the external ring and consist of self-sufficient units measuring 40 meters wide, 25 meters high, and 60 meters long. Pods will be interconnected to create operational areas. Pod types include mixed-use pods, residential pods, specialized pods, mixed-use pods, residential level, community level, and agricultural level. The assembly and construction of the first settlement must follow a well-defined schedule, adhering to a critical path and logical sequence of activities. Unlike a conventional settlement assembly in outer space, this connected settlement will employ a novel sequence and methods. Prefabricated, finished models built on Earth and dimensioned to fit a space elevator cabin will be transported to orbit and connected like pieces of a puzzle. One of the most important features of the connected settlement is how transfer of passengers and cargo can be implemented between the rotating settlement and the fixed space elevator terminal. To allow safe and efficient transfer, we will recommend the following. Now we're showing you how we transfer the pod from the rotating ring to the fixed platform. We move the pod with a mechanical arm with a forklift. Obviously, we grab the grabbing bar, we lift the pod up, and we move it to the fixed platform. Then, to move it back to the maglev track, we have another mechanical arm with the same forklift that is based on the rotating ring, and it moves the pod from the fixed platform, obviously, to the maglev track. The settlement's functionality depends on its systems and subsystems. While some systems such as power, food production, and life support are essentials, others are equally critical to ensure smooth operations. The systems can be categorized as follows: basic systems, technical systems, service systems, and social systems. These are the daily metabolic needs per person. The settlement will be equipped with a residential system to support several thousand people with expansion and flexibility capabilities due to continuous requirements. Settlement residential units will allow around 30 square meters per person in a residential system located in the more external tourist pods in the upper level. At the same residential level and interconnected in clusters will be located all residential related activities and infrastructures such as primary schools, nurses, etc., etc. They will be housed in specialized pods. We have 2 by 2 kilometer solar arrays generating 800 megawatt each. Settlement requirement is 30 megawatt. Remaining power goes to the earth with a cable system. The healthcare in Apex and furthermore in future settlements will represent the most advanced systems to ensure disease-free environment, real-time intervention at any cell alteration detected, and no spreading of any disease due to the limited enclosed space. The healthcare will be guaranteed by all people to have their health records digitalized and accessible by the healthcare system. The sensor constantly transmitting data to medical center individual utilizing an injected nanochip, the permanent updating of all biosensor data by AI monitoring, and instant intervention at any alteration monitored. It will be obvious to forbid any production nor utilization of smoke, drugs, and the alcohol drinks only on a limited scale. The proposed space elevator and settlement combination represent a paradigm shift in our approach to space development, especially to our first steps in a new territory. With its capabilities, we will be able to transfer to space huge payloads at very affordable costs. Such capability will depend mostly on cable. For this reason, settlements equipped with space elevators will help our exploration and development of our solar system. A solar system network of space transportation infrastructures promoted by the utilization of the space elevator can be the final goal and main instrument to developing a major space economy. Such technological development and breakthrough should be in the priorities list of any space agency. For these reasons and motivations, the implementation of space elevator technology should be considered a major breakthrough and a paradigm shift in space development.